All right, fifth grade. We are going to be looking at your POD and math review. So our first question is our problem of the day. And Lana has this tower that she built, and we need to know the total volume. So I kind of dissected the towers. I made them into two different towers when I did my own sketch. So I've got this tower with a length of 5, of 2, a width of 5, and a height of 4. So I'm going to plug those numbers into my formula. 2 times 5 times 4. And I need to know the total volume, which means I'm finding the volume of one, and then I'm finding the volume of another. So then I've also got this prism, excuse me. And I know that its length is 10, its height is 4, and its width is 2. So I'm going to plug those numbers into my formula. Oops. So now what I need to do is I need to solve this equation, and then I need to add my total volumes. My total volumes will always be in cubic units, okay? So let's see, 2 times 5 is 10, 10 times 4 is 40, plus there's another 40, times 2 is 80. And I know 80 plus 40, well, if I do 8 plus 4, that's 12. I know 80 plus 40 is 120, and that will be in cubic centimeters. Or I can write it 120 centimeters cubed. That's how I would find the total volume of two different prisms. Let's move on to our math review. I have got Mr. D has 6/4 pounds of Takis, and Miss Mulder has 7/6 pounds of Takis. Not a bad problem to have. And Mr. D says I have more, because Mr. D is always like that. So let's look at it just using what we know about fractions. I know that 7/6, I know this is a fraction greater than 1. So I know 6 goes into, if I were to divide this, I know 6 can go into 7 one time. And then I have one more left to get to 7. So that's 1 and 1/6. Then I have Mr. D over here. And I know 4 can go into 6 also one time. But then there's 2 left over. So that leaves me with 1 and 2/4. Well, I know 1 and 2/4. I can write it as 1.5. I know they're equivalent fractions. So when I think about it, I know the bigger the denominator, the smaller piece that I have. So I would rather have 1.5 than 1 and 1/6. So I'm going to say that 1.5, Mr. D is correct. He says he has more, and he absolutely does. He has more Takis. All right. When I look at 3 and 3/4 minus 4/5, I'm already realizing something. I'm knowing that 4/5 I think is bigger than 3/4. So I'm going to put my whole number on hold here. I'm just going to put it in a box, and I'm going to do 3/4 minus 4/5. And already I know that I can't subtract these fractions. I can't subtract these fractions because they don't have a common denominator. So I need to figure out what that common denominator would be. Watch what I do. Let's see, I've got 4. I'm going to list out my multiples of 4. 4, 8, 12, 16, 20. I bet that's my winner. I don't think 5 goes into any of those. 5, 10, 15, 20. 20 is my winner. Okay, so I need to get these fractions to have a denominator of 20. So that means I would multiply 3/4 by 5, and what I do to the denominator, I have to do to the numerator. So I have 15/20, and 4/5 to get to 20, I have to multiply by 4, numerator and denominator. And when I see my fractions with the same denominator, I can't do 15 minus 16 because 16 is greater. I would be in the negatives. So I need to go up to my whole number, and I need to take one whole and make this down to 2, and one whole would be equivalent, if I'm thinking about 20ths, to 20/20. So now I need to add 20/20 to 15/20, and I get 35/20 minus 16/20. And when let's see, if I do 35 minus 10, I have 25. 25 minus 6, well, that would be 19. And I can't forget my 2, my whole number up here. So 2 and 19/20. So close to being 3. 19/20 is just 1 away from being 3. I'm so close to being 3. So that's what I needed to do. I needed to take, kind of borrow from that whole number and turn it into a fraction. All right, if I have how many ounces are in 45 pounds? Well, the first thing I need to do is set up my conversion. If I have 16 ounces, I know that's equal to 1 pound. So I like to do this, match them up, and say, well, how did I get from here to here? I needed to multiply by 45. 1 times 45 gives me 45. So now, if I'm doing it to this side of the equation, I have to do it to this side of the equation. So I need to multiply 16 by 45. Again, I'm going from big to little. I need to multiply. So 45 times 16. I'm going to break this up so it's easier for me. 45 times 10, that's a quick 450. 45 times 6 is 12, 4, 5, 720. So there are 720 ounces in 45 pounds. And that answer makes sense because over here, my ounces, it takes me more ounces to get to 1 pound. So I'm going to have more ounces than I would pounds. So I can put a square around that so it's very clear to see that this is my answer. My next problem is one that we've been working on a lot. So I take a walk for 1/6 of a mile every day. And I want to know how many days it would take me to walk 3 total miles. So my total is 3. So I'm going to start out with my 3. And I know that when I begin with a total, I'm dividing. So with my model, I want to cut this into 6. I cut it into thirds, and then I cut that in half. I cut it into thirds, and then I cut that in half. I cut it into thirds, and then I cut that in half. I now have 6. So if I walk 1/6 every day, so this is 1 day, it will take me 6 days to walk 1 mile. I want to know how many days will it take me to walk 3 miles. So if I just follow the pattern, 12 days will be 2 miles. And 18 days will be 3 miles. So it will take me 18 days. The way that would look as an equation is I'm taking 3 and I'm dividing it by 1/6. When I divide, I flip my second number. So now this has turned into 3 times 6/1. And I can put 3 over 1 because it's a whole number. And 3 times 6, 18 over 1, and 18 over 1 is the same thing as saying 18. So this is how I would do it with an equation, and this is how I would do it with a model, okay? To find the area of a rectangle, I drew a rectangle, and then I labeled I know area equals length times width. So I have my length, and I have my length, and I have my width, all right? So I want to know what my area is. So I know, well, I can just set up 6 2/3 times 3 3/4. But here's the deal. I can't multiply mixed numbers like that. I need to convert my mixed numbers into a fraction greater than 1. So let's watch how I do that. I do 6 times 3 is 18, plus 2 is 20. I keep the same denominator. So 6 2/3 is the same thing as saying 20/3. Then I do 4 times 3 plus 3. So that's 12, 13, 14, 15, and 15/4. Now I multiply across. Well, when I multiply fractions, I multiply across the numerator and I multiply across the denominator. So 3 times 4, I'm taking the easy one first, guys, sorry. And 20 times 15. Well, if I know 15 times 10 is an easy 150, I can just double that to make it 20. So I know 150 doubled is 300. So I can be 300 feet squared. Let me check my unit. I want to make sure I'm using my unit accurately. Oh, yards. Sorry, guys. 3/12 yards square. Or if you're the kind of person that wants to take it a step further, you can do 300 divided by 12. So if I have 300 divided by 12, 12 goes into 30 2 times, 60, and I know 12 goes into 60 5 times. So I can also say 25 square yards. Either one of these answers would do. Okay, again, we have another competition problem, I guess. So Miss Shames has 5/10 of a pizza. Miss Mulder has 3/6 of a pizza, and then she has 1/10 of a pizza. And Miss Mulder says she has more. So is she right? Is Miss Mulder erroneous? Is she wrong? So when I think about fractions, think about what you know. You don't need to do all this fancy converting and all that. You can just think about what you know. I know 5/10 is equal to 1/2. And I also know 3/6 is equal to 1/2. So when I look at it, we both have 1/2, but Miss Mulder has 1/2 plus 1/10. So Miss Mulder says she has more, and yes, she has more. She has only a little bit more, but she still has more. So Ms. Mulder is correct. 5/10 is less than. All right, and that's how I can prove my answer. Thanks so much, guys, for watching. Remember, check your work, revise your answers. A mathematician can always make mistakes and go back and fix their mistakes.